Hello everyone, my name is Hariharan. Today we're going to discuss about the topic named Six Sigma measures. It is one of the key topics in Six Sigma because it helps to measure whether the process is good or not. Before getting into the topic, let's discuss what is meant by Six Sigma. Six Sigma aims at reducing process variation and improving quality. It uses more rigorous standards for process capability than older quality systems. In general, in older quality systems, they used to use 3 sigma. It is 99.7% accurate, but it means in 1000 products there will be 3 defects alone. But now in 6 sigma, per million products it is under 10 only the defects. So it's very much improved than the older system. This ensures consistent conformance to customer defense specification. Okay, let's see the Six Sigma measures. Process capability and process capability indexes. Process capability index is a statistical measure of a process ability to produce output within the specification limit. Here, the specification limits is defined by the users or designers. Moreover, by using capability indices, we will confirm whether it is in the range or not. Let's discuss that further in the further slides. These indices will help identify if a process is improvement, if it is centered, and how consistent it is with the target. These are all the three index. CP means generally the designer or user will set the higher limits. It is considered USL and lower limit as LSL. Divided by Six Sigma will be given as CP. It measures process potential spread assuming it is center. So generally it is used to find how much the spread is happening. In terms of CPK, CPK is equal to min of upper limit minus mean divided by 3 sigma, comma mu of minus low limit 3 sigma. So it helps to measure the capability according for shift from center. Similarly, CPM equal to upper limit minus lower limit divided by 6 root of sigma square plus mu minus t the whole square. It helps to measure how it is deviating from the target. So these three indices plays a key role in Six Sigma measures. So generally this formula will produce certain results based on the value range and we can tell it is good or not. For example, generally if the index is produced less than 1, it is considered not okay for the process. So we need to make some alteration using DMINE. And if it is CP equal to or CPT equal to or CPM equal to 1, it's okay, just capable like sigma 3 sigma. Similarly, if CP or CPK or CPM greater than or equal to 1.33, it's considered good. Similarly, if it is greater than or equal to 2, it's considered very good. So we can go for it. Understanding specification versus control limits. Specification limits is generally is defined by the users or designers. For example, consider we need to fill the 500 ml for the water bottle. The designers or user will set 490 ml or 510 ml is okay for the process. If it is above or below that, it is not considered okay. So to define and do this, we can use control limits. Formula for this is USL equal to mean plus 3 sigma for lower limit mu minus 3 sigma. These specification limits guide what is acceptable to the customers. Control limits helps monitor and maintain the process stability. Let's see the importance of upper limit and lower limit. Upper limit and lower limit are not arbitrary. They are driven by design, customer, and market. We should not adjust this according to our wish to improve the value and accuracy. Rather, we need to set it properly to get the more appropriate value. Large tolerance ranges can make a process appear better than it is. Six Sigma doesn't mean stretching limits to fit capability. So we need to set a proper value. Otherwise, it is no use. High precision industry need extremely tight tolerance, like Istokis. Let's see some example for this. So, Wastra is apparel manufacturer and one of their products is Excel shirt for which the chest size is 40 inches. The LSL and USL for Excel shirt are set of 41.5 and 42.5 respectively by the company. A sample of Excel size shirts manufactured by Wastra had a mean chest size of 42 inches with a standard deviation of 0.1 inch. Calculate the process capability index for the Excel shirts manufactured by the Wastra. Since the mean value is same as the process target, the process capability index CP is given by. Here the upper limit is clearly given as 42.5 and lower limit is 41.5. and sigma is 0.1. By applying the value, we get the value of 1.667. In the chart, we see if it is greater than 1.33, means it is generally considered. So it is in the this process is generally considered good. It is the next example. The thickness of computer chip used in a big data server should be 17.75 mm and the corresponding LSL and USL of 17.10 mm and 18.50 mm respectively. A sample of 50 chips was tested for the thickness and the data is shown in table 17.8 calculates the process capability for the process. Okay, based on the given data and given value, we can apply the formula to find the process capability for this process. By applying this formula, we get to know that its value was 0.1765. So we get the average thickness of chip is 70.75 mm and the standard deviation is 1.22 something. Since the average thickness is not at the center of the LSL and USL, we use the following equation to calculate the process capability index. But since the value is not that much good, we won't say it's good. Okay, let's see the real world misuse of sigma. Some companies define defects leniently to achieve Six Sigma levels. For example, rather than keeping the proper upper limit and lower limit, they can flex it over. So they will get a better result, but it won't give a better result. So relaxing limits does not improve through quality. Let's discuss another case study is related to issue. 2006 GSLV F02 crashed due to 1 mm bore error, 16 mm versus 17 mm. Cost $62 million for a part worth $1,200. So this minimum tolerance is not acceptable in certain use cases. So we need to look in it carefully. So sometimes Six Sigma is not sufficient, tighter standards are needed. So our final thoughts for this is process capability is about meeting real customer needs. CP, CPK and CPF helps to identify the to measure the quality properly. Six Sigma is powerful, but context is very much important. So precision alignment and understanding of limits is key to success. Thank you.